that's a pretty cool solar-powered system there. Yeah, you want to talk on camera about it?
Sure, I'll give it a shot.
All right, tell me, who are you? What'd you bring?
My name is Mark Havran, and I built this solar-powered bicycle.
That is nice. So, what's a solar-powered bicycle?
I'm here at Maker Faire with Mark Havran. He's the reason I came down to Maker Faire. Normally I'm often showing up as an exhibitor with stuff to show. Here I wanted to be nothing but a spectator, and especially here to spectate and examine the project that Mark here has been working on, which he alluded to in some emails to me, and that had me increasingly fascinated. And so I'm going to have Mark do a pretty deep technical dive in all aspects of this bike.
So it's an e-bike with a solar panel trailer that charges the bike while you ride. So for about each hour of full sunlight, I get about 20 miles of range with pedaling.
What you see is quite clearly a solar-powered recumbent bicycle. It's got a direct drive grid motor on the front, solar panels on a trailer.
How long have you been working on this?
I built my first version in 2008, so it's been kind of on and off for a while now, and this is the latest version.
Mark has been conceiving of this idea for now over 10 years and has gone through multiple iterations of solar panel builds, of motor drive systems, starting off with the 24-volt Curry-style chain drive to the rear wheel back in 2006, and has in his mind an ambition to not only build a viable solar-powered bike, but to then make one that he tours around the world.
And what was your inspiration? Why build a solar-powered e-bike?
Well, in 2006, I did a bicycle tour of Italy on a traditional bike, 2,000 miles over 2 months on a fully loaded touring bike, and Italy turned out to be a very hilly country. On those hot sunny days, I figured it would be great to get a little bit of help getting up those hills. So I started looking into e-bikes and solar panels, and just all seemed to go together.
And that's something that in this day and age is now viable. I myself have been a huge solar skeptic over the years. Mark even sent me some emails he sent from 10 years ago asking about advice and input for solar design. And I always thought, solar, like, yeah, you can get a little bit of power from some panels, but what a big cumbersome thing to carry and tow behind the bike for, what do you get, 100, 150 watts? But as we'll see as we do the deep dive here, it actually is totally viable.
What are you doing with it?
Oh, I'm going to take a quick victory lap once around the world, once it's done. So
Just one quick victory lap around the world, just real quick.
Round the world trip on a solar e-bike.
That's incredible. You got that planned already?
I do. Heading out first segment in August of this year.
All right, good luck. Enjoy. Around the world, just a quick little lap around the world. No big deal. I could get into that.
My first motor on there was a 24-volt mid-drive. My second one was a BMC geared hub, and then I wanted the roll-off internally geared hub in the back. I'm finding that on flats I'm getting around 10% extra range just from regen, and when I'm riding in the hills around Oakland, I get 20 to 30% extra range thanks to regen. So that was just a huge surprise to me. This is a battery storage box, and it's a place to mount some of the switches and so on. I created a foam blank that I carved down to just sanded it down by hand to the shape that I wanted, just rounded off the corners and kind of eyeballed the suspension travel and just fitted it to the frame of the bike. The batteries are in here are not held at all by the carbon fiber shell of this. They're actually bolted directly to the frame.
And that seems like quite a small amount of battery capacity for somebody touring on a bike.
I'm a little bit obsessed with keeping the weight down, so I'm kind of trying it with as few batteries as possible. So the breadboard is an Arduino and a little motor controller and a Bluetooth module, exclusively just controlling the tilting mechanism on the solar trailer. So there are a couple of light sensors on the trailer. Those are connected to analog pins on the Arduino, and I very simply just compare the two outputs, and if one of the light sensors sees more light than the other, I tell the panel to tilt in that direction until the two outputs are equal. So they're mounted at about 90 degrees to each other, at a 45-degree angle to the panel. I'd say 90% of the time, it's pointing to, I couldn't improve on where the panel position is, and I can double check that by looking at the watt output of the panel as shown on the new solar firmware. And I've got a solar charge controller here that's managing the energy from the solar panel, converting it into the right voltage for the battery. So there's a little Bluetooth module on there, and that's to help with debugging. I have that connected to my iPhone, so that if the behavior of the panel is a little bit unexpected while I'm riding and I look back and I see, oh, it looks like it didn't adjust the way I expected, I just press the button and make it tilt one way or the other from a distance.
And what kind of distance can you do this from?
Someone's checking out the bike and I'm on the other side of the street, I can demonstrate the tilting mechanism without having to cross the street. And this weighs 30 pounds.
That's including the wheel, the boom tube, the actuator?
Everything.
Wow. Yep, that is not heavy.
So the support panel, this red panel you see, is something that I constructed. I took 1-inch rigid foam and covered it with fiberglass and epoxy. Basically, I copied the techniques used for making surfboards, and creates a very stiff platform for mounting the solar panel. So one goes right here. I'm going to try to hook it up with a wireless charger. That's the next project.
For your time, I love looking at it. This is wonderful. Fiberglass, custom built. Proud of you. Keep going, man.
There's a little bit of mileage here just riding around Maker Faire, but most of what's on here right now is the 107 miles that I did on Friday, riding down from Oakland to San Mateo over the Dumbarton Bridge for locals who are wondering how I manage that. And so these are the stats. So the bike is fully charged right now because it's been sitting out in the sun here at Maker Faire. And so we have 111 miles total since Friday morning. It's Sunday afternoon now.
And so this is the solar panel. So this is a custom solar firmware. We'll talk about that in a bit. But that, so right now you're getting just 30 watts from the sun, but that's because the batteries are at 41.9 volts. So you're completely charged.
And the lights are on, so they're consuming a little bit. Otherwise, it would be tapering off to less than 5 watts once they're up and running.
Yeah.
0 human watt hours because we're not traveling right now. So the total solar watt hours consumed since Saturday morning, and the total watt hours consumed by the motor since I started. And you'll note that the net solar watt hours are reading 0. So I started out with a full battery Saturday morning, and the battery's full now again, so we've come full circle.
So that's sort of the goal in solar commuting, is to ultimately have 0 watt hours per mile at the end of every day.
That's the idea. I mean, depending on the route and how far I'm trying to go, I'll probably end some days with a full charge, and more likely I'll end most days with a depleted battery, and then get some of the charge in the morning before I head out, and charge along the way when I take breaks. So I mean, right now I only have 4 LiGo batteries, so 400 watt hours. So with the current panel, that means that if I stop for longer than 2 hours, I can't capture all the solar energy that I potentially could. That's one of the trade-offs in terms of how much battery weight you're carrying.
And so 8.2 watt hours per mile, is that typical of your consumption rates for this recumbent bike?
That's a little on the low side. When I'm shooting for maximum distance, I'm shooting to be around 8 or 10. When I'm commuting or riding in the hills and I don't care about distance, I may use as much as 15 to 20, and I'm trading off speed and performance for distance. But 8 to 10, at that point, I'm typically doing about half the work as a motor. So my goal ultimately is to double the distance I can do in a day on a long distance, fully loaded touring bike.
So for the human statistics, so for that 110 miles, you put in 807 human watt hours, which is, if I look back here, pretty much the same. I mean, your electrical input was 990, and given the efficiency of the motor for mechanical watt hours, it seems like you're pretty much paired 1-to-1 with the motor. Was that a design goal in the development of this vehicle, to sort of equalize motor power with human power?
I never thought about it directly in those terms, but I think if my goal is to double my daily distance, that's roughly right.
Mark, what is it that you've got right here?
So this is my second panel that I ever tried to create by soldering my own cells together and laminating it with this 2-part silicone encapsulant. And these cells right here are for extraterrestrial use, for satellite use. They're dual junction gallium arsenide.
When did you get them?
And I got these in
2008 on eBay from someone that I suspect may have been a NASA employee who was just selling some off-spec rejects that they were using for some project. So I couldn't get any more afterward, but they were very easy to solder together, and they produced 2.5 volts per cell.
That's crazy.
And it's about a 50-watt panel, which
so
is
2.5 volts. And how many cells in total are on that?
I would have to count.
Huh.
2, 4, 6, 8, 10, 12, 14, 16 times 1, 2, 3, 4, 5, 6. So 96.
Yeah, something high like that.
So they're not all
so they're not in series. I was going to say that would be
several
lethal.
strings. I forgot how I wired them together. Yes, I remember now. See, this is
Yeah.
these two halves are separate. So 2, 4, 6, 8. I think it's 8 times 2.5 is the nominal voltage.
And so what was the theoretical efficiency of these cells? It's at the time, was it 25%? You're saying for gallium arsenide?
Oh, I hope I'm remembering that
Yeah.
right now. I believe if they were fully on spec, they would have been, I believe, over 30%.
And this was your very first ever panel you made from scratch, from bare cells,
The first
doing
one
your
that
own
worked,
soldering.
yeah.
Okay.
The first one I tried to manufacture was out of traditional silicon solar cells, and I ended up destroying it when all the cells cracked when I attempted to encapsulate it using a vacuum bag and a giant 3x4 foot solar oven that I created for the purpose. This is one
That's
of my
your
2
Curry
original
battery.
batteries.
Oh,
Yeah,
wow.
so
Yes, 7 lead
Velvet.
acid amp hours that gets you.
and it's a tricky proposition keeping it light enough and having enough solar, because
Yeah.
if you're limited to not charging, not plugging in every night, then you're relying just on the solar, and you need to be able to get enough to offset that weight, even when you have some
Cloudy
cloudier
days,
and
yeah.
some rainier days. So
Speaking of lights, I'm curious about the ceiling lighting here. Did you have an issue with direct light and decided you wanted a reflective light ceiling?
I came across someone who did something somewhat related to this on YouTube and just thought it was neat and wanted better lighting in here. And this is like a high CRI index, white light, and it's just.
So
it's
are
just
these LED
crushed aluminum
bulbs?
It's an LED strip, yeah, and I
yeah.
just fabricated this in here, so it just acts as a reflector.
Yeah.
And
It's a nice diffuse shadow-free lighting, kind of perfect for a little workshop.
And heat lamp here for when I was doing like the vacuum bagging,
Yeah.
and to accelerate the curing.
And this is on a pulley system to get it right up into the...
Exactly. If I'm doing something smaller and I can get it down, I can lower it.
That's so cool. Is this documented anywhere online where people could follow along?
Yup, I'm on Instagram and Twitter as a SolarEbike. You can find me.
On Instagram and Twitter. SolarEbike on Instagram and Twitter. Around the world, just a quick little lap around the world. No big deal. I think I could get into that.